Chapter 6.1 is verifying trigonometric identities. So we're going to have a trigonometric equation, and we're going to show that one side of the equation equals the other side using identities. So what we're going to do to start these is we're always going to start with the more complicated side. So find the more complicated side of the equation, and then we're going to try to make it look like the other side by using certain identities, and if necessary, one of these following techniques. We might need to rewrite it in terms of sine or cosines. We might need to use factoring or distributing, or separating or combining fractions, and we might have to multiply by a conjugate. Okay, so we're going to be using all of these techniques in these next examples. So remember these identities because we're going to be using them: the reciprocal identities, Pythagorean identities, and the quotient identities. Okay, so pretty much just going to do a bunch of examples for this section. So verify the following identities. So the first one, we have secant of x times cotangent of x equals cosecant of x. So we're trying to show that secant x times cotangent x equals cosecant x. So what we want to do is work with the more complicated side. So the one that's more complicated looks like it's this side, right? Because there's more going on. There's two trig functions over here. So let's start with that. So we have secant x times cotangent x, and we're going to keep on applying identities and maybe some algebra tricks to this until we end up getting cosecant x. Okay, so what we want to do here for this one is let's rewrite both of these in terms of sine and cosine, using a reciprocal identity for secant and the quotient identity for cotangent. So we can rewrite secant as 1 over cosine x. So there is the reciprocal identity for secant. We can rewrite cotangent as cosine x over sine x. Okay, so when you're doing these problems, you might work yourself into a dead end and it might not work. You might have to start it over again and do it a different way. But for this way, just always keep in mind that we're trying to end this with cosecant x. So what we want to realize now is that the cosines cancel, and we're left with 1 times 1 over 1 times sine of x. So we're left with 1 over sine of x. And keeping in mind that we want this to equal cosecant, 1 over sine does equal cosecant of x because they're reciprocals. So once we get that, we're good. Put a little check mark. We just showed how one side of the equation equaled the other one. We just verified that they were the same. Okay, next one we have sine x times tangent x plus cosine x. We want to show that that equals secant x. So once again, we're going to work with this left-hand side of the equation because it is more complicated. It's a lot easier to cancel terms than it is to add terms from the less complicated side. So sine times tangent plus cosine. Okay, so once again, let's rewrite all of this in terms of sine and cosine. So that means we just have to rewrite tangent as sine of x over cosine x. Okay, and now what we can do is we can multiply sine of x times sine of x, which is sine squared x. So sine times sine, sine squared. All of that plus cosine x. And now it doesn't look like this helped us very much, but it did. We're trying to make this look like secant. So we started with two terms, right? Separated by addition. We want this to equal one term. So to do that, a little hint is we want to rewrite this as one fraction, which means we need a common denominator. And the common denominator would be cosine because of this first denominator. So we're going to multiply by cosine x over cosine x. Okay, so now we're going to get sine squared over cosine plus cosine times cosine is cosine squared over that cosine. And now they have the same denominator, so we're going to combine these into one fraction. We're going to write that as sine squared plus cosine squared over cosine x. So we just combine the fraction, common denominator. So this numerator, sine squared plus cosine squared, that equals 1. That's a Pythagorean identity. So sine squared plus cosine squared equals 1. So that's 1 over cosine x. And once again, keeping in mind that we wanted this to equal secant, this is equal to secant because they are reciprocals. 1 over cosine equals secant. So we're good. We just showed that one side of the equation equaled the other side. Okay, and the next one. So cosine x minus cosine times sine squared x equals cosine cubed of x. So once again, working with the left-hand side here. So we want to show that this simplifies to cosine cubed. So once again, we have two terms. We have this term and this term separated by subtraction. So since we start with two terms, we want it to be one term. We want to somehow combine these into one term. So taking a look at this, both of these terms have cosine in it. So we can actually factor out cosine x. When we factor out a cosine x, we're going to be left with 1 minus sine squared x. Okay, so it might look like this is a dead end, but something we can actually use an identity here and make this work out for us. This portion in the parentheses right here, this is a Pythagorean identity. So it may still not look like it, but this is going to be from sine squared plus cosine squared equals 1. We could actually rewrite that and subtract sine squared on both sides, and that would give us cosine squared equals 1 minus sine squared. So 1 minus sine squared is right here, and it's right here. So we're going to replace that with what it equals. It equals cosine squared. So this is going to be cosine x times cosine squared x. And that's going to be cosine times cosine squared, which is cosine cubed. Okay, so we showed that the more complicated side simplified to the less complicated side. Okay, next one, we have 1 plus sine x over cosine x, and we want to, and it equals secant x plus tan x. So we can actually choose either side here. They both look equally as complicated. Let's just work with the left-hand side again. So I'm going to work with 1 plus sine x over cosine x. So we have one big term here. This is one big term with division. We want to make it equal to secant x plus tangent x, which is two terms. So that means we need to start by chopping this fraction up into two separate terms. So we're going to give the denominator of cosine to both terms in the numerator. We're going to give it to 1 and the sine x. So it's going to be 1 over cosine x plus sine of x over cosine x. So that's just splitting up the fraction, separating the fraction here. And keeping in mind what we want this to equal, 1 over cosine x, that equals secant x because they are reciprocals. 1 over cosine equals secant because they're reciprocals, plus sine of x over cosine x, that equals tangent x based on the quotient identity. Tangent is sine over cosine. So we're actually done already. That was 2 steps. We showed that the left-hand side equals the right-hand side. So we'll do 2 more. So for the next one, we have cosine x over 1 plus sine x plus 1 plus sine x over cosine x equals 2 times secant x. So definitely work with the left-hand side here first because it's more complicated. So we have 2 big terms here. We have this term and this term. our answer, what we want this to end up equaling, has only one term there. So anytime that happens, we have to combine the fractions. So that means we have to get common denominators, which is going to be a little bit messy. So the common denominator is going to be cosine of x times 1 plus sine of x. So it's just both of these denominators multiplied together for our least common denominator. So we have to multiply this one on the right by 1 plus sine of x over 1 plus sine of x. We have to multiply the one on the left by cosine of x over cosine of x. So that will get us to the least common denominator that we want. So for the one on the left, cosine times cosine is cosine squared. And for that denominator, don't distribute the denominator, just leave it as cosine x times 1 plus sine x. For the term on the right, we have 1 plus sine x times 1 plus sine x. I'm just going to write that as 1 plus sine x squared for now. And that's going to be over that same denominator, which is why we multiplied it by those terms. Okay, so now that they have the same denominators, we can combine them into one fraction. That's going to be cosine squared x plus 1 plus sine squared x, or sine x all squared, over cosine x times 1 plus sine x. Okay, so let's work on simplifying that numerator here. So that portion right here on the right, 1 plus sine squared x, that is equal to 1 plus sine x times 1 plus sine x. We can FOIL that out. We can distribute that and expand it. So that would be 1 plus sine x plus sine squared. Combine the middle terms, we end up with 1 plus 2 sine x plus sine squared x. Okay, so that is just foiling and combining the middle terms. And this is going to be, just filling that in now, cosine squared plus 1 plus 2 sine x plus sine squared x over cosine times 1 plus sine. Okay, so for this numerator, there's actually an identity here. We have cosine squared and a sine squared. So we can use our commutative and associative laws of addition to rewrite that as cosine squared plus sine squared. That is equal to 1. So since that is equal to 1, we can just write 1, and then it's plus this 1 plus 2 sine x. So we have 1 plus 1 plus 2 sine x. So that was the Pythagorean identity. Divided by cosine x over 1 plus sine x. And we can combine the 1 plus 1, it's just 2. 2 plus 2 sine x. And there's pretty much just one more step here. The last step is factoring the 2 out in the numerator. So if we factor that numerator, factor a 2 out in the numerator, we're left with 1 plus sine x. And that's going to cancel with the 1 plus sine x in the denominator. So we have 1 plus sine x divided by itself cancels. This leaves us with 2 divided by cosine x. Taking a look at what we wanted originally, we wanted this to equal 2 secant x, while 2 over cosine x is equal to 2 times secant x because they're reciprocals. Ooh. Okay, so a bunch of steps here. We had to get common denominators to combine the fractions. We had to FOIL out a binomial trig expression. We had to factor. We had to use the Pythagorean identity, cancel common factors, and use a reciprocal identity. So definitely a lot going on there, but still doable. Just take it one step at a time. Okay, so let's do one more example here. So we have sine x over 1 plus cosine x equals 1 minus cosine x over sine x. So once again, we can choose what side we want to start with because they both are the same complexity. So let's just work with that left-hand side. Okay, so both of these are just one big term. So we want this side to equal 1 minus cosine x over sine x. So something to keep in mind here, or something to recognize before we even start this, is we have 1 plus cosine x here and 1 minus cosine x here. These are conjugates. So almost anytime this happens, what you want to do is multiply the numerator and denominator by the conjugate, in this case of the denominator. So if we multiply this by 1 minus cosine x over 1 minus cosine x, we can rewrite it like this: sine x times 1 minus cosine x divided by 1 plus cosine x over 1 minus cosine x. So just rewriting it. So notice that when we did that, that put this 1 minus cosine x up in the numerator, which is where we want it. And let's see what happens to this denominator. So when we're multiplying conjugates, we can do a shortcut. And well, hopefully we remember what conjugates are. They're the same two terms. One's addition, one's subtraction. So if we multiply conjugates, a plus b times a minus b, those are conjugates. The shortcut is they end up being a squared minus b squared. So when we're multiplying 1 plus cosine x times 1 minus cosine x, what we end up getting, I'm going to leave the numerator alone. What we end up getting is the first one squared, so it's 1 squared minus cosine squared. So a squared minus b squared, a was 1, b was cosine, so 1 squared minus cosine squared is just 1 minus cosine squared. Okay, so that's the shortcut for that. If you did not know the shortcut, you would have to FOIL it. Okay, so that would work also. Okay, so in this denominator, we have 1 minus cosine squared. This is actually a Pythagorean identity. Sine squared plus cosine squared equals 1. If we subtract cosine squared on both sides, we get sine squared equals 1 minus cosine squared. So that whole denominator just becomes sine squared, because it's the whole thing is just equal to that sine squared. Okay, so now we have, let's take a look back at what we want. We want this to equal 1 minus cosine over sine. We're almost there. We can recognize that sine of x is going to cancel with one of those sine of x's down in the denominator, so I'm just going to cancel off the squared. We're going to be left with 1 minus cosine x over sine x, which is what we wanted it to equal, so we are done. Okay, so make sure you know those identities that I put on that first page and those techniques. Always work with the more complicated side and try to use the identities and those techniques to simplify it to the simpler side. Okay, so that's it for this section.